Chapter 16 is about oxidation and reduction. The reason we're doing it now is because we just talked about oxidation and reduction reactions, and so it just seems to fit in here a little better. We're not going to cover all of this chapter. We're only going to cover the sections that have things that are listed on our course outline. So we're going to start with section 16.2, definitions of oxidation reduction. We just covered this in chapter 7. Well, it doesn't hurt to go over it. One way of defining oxidation is the gaining of oxygen. This is where the term oxidation came from. We just learned that oxidation is loss of electrons, oil rig. Oxidation is loss of electrons. Another way to think of it is that it's the gaining of oxygen. So rusting, we have iron reacting with oxygen to form iron oxide. The iron has gained oxygen. That's another way of recognizing oxidation. That's a slow oxidation, happens very slowly. Rapid oxidation would be something like combustion. Methane reacting with oxygen to form carbon dioxide and water. Here the carbon is gaining oxygen. So if oxidation is gaining oxygen, then reduction is losing oxygen. Redox reactions do not always involve oxygen. So here's an example that does, and here's an example that does not. We learned earlier that a metal reacting with a non-metal is going to be an oxidation reduction reaction. Another way to define these is in terms of loss and gain of electrons. Oxidation is loss of electrons, reduction is gain of electrons. So if we look at this, it might not be immediately obvious that electrons are being transferred. But lithium chloride is an ionic compound, right? What are the ions in lithium chloride? Li has what charge? +1. And chloride has what charge? -1. Over here in the reactants, we had lithium metal, the element, it had no charge. Now it's got a positive charge. It got a positive charge because it lost one electron. Where did the electron go? It went to one of the chlorine atoms. Here chlorine had no charge, and now chlorine has a -1 charge. So the lithium gave an electron to chlorine. It's an oxidation reduction reaction. Same idea up here. Because we're forming an ionic compound, we've got lithium and oxide. The oxygen gained 2 electrons, the lithium lost electrons. The way this is balanced, all of the electrons that were lost got gained by somebody else in this group, and it's all good. If one substance loses electrons, then another has to gain them. You can't have orphan electrons. You can't go to the pound and adopt electrons. You have to get them from someone. In this reaction, seemed like I missed one, but I didn't. So here we have hydrogen and oxygen reacting to form water. And we can look at this and say, well, that's not an ionic compound. How do we see that there are electrons changing? Well, that's a little harder. But we can see that here, hydrogen had no oxygen, and now hydrogen has oxygen. Hydrogen was oxidized. And that makes it a reducing agent. So as if you weren't confused enough today, I have to throw this at you. So the reducing agent causes something else to be reduced. So let's think about movie stars, right? Movie stars have agents. Do agents star in the movie? No. They get the jobs for the movie star, and the movie star stars in the movie. That's why they call them movie stars. They star in movies. The agent arranges for them to be in the movie. A reducing agent causes something else to be reduced. So it itself is oxidized. In this situation, the oxygen is reduced. That makes it the oxidizing agent. The oxidizing agent causes the oxidation of something else. Oxygen being an oxidizing agent kind of makes sense. So to review this definition, oil rig, oxidation is loss of electrons, reduction is gain of electrons. So oxidation, the loss of electrons, reduction, the gain of electrons. The oxidizing agent is the substance that's being reduced. The oxidizing agent causes the other thing to be oxidized. The reducing agent is the substance that's being oxidized. It causes something else to be reduced. It's an agent for the reduction of something else. Any questions? Too many, yeah. Remember my son once told me about an experience he had in calculus class, and teacher went over a bunch of stuff, and I said, does anybody have any questions? And he's like thinking, I have lots and lots of questions, but I can't put them into words at this point, right? So I would imagine that lots of you have questions in your mind, but they're just not even going to come out. So let them percolate around and ask me when you figure out what they are. Okay, identifying oxidation and reduction. So identify the substance being oxidized and the substance being reduced. So let's remember oil rig. So the substance being oxidized, oxidation is loss of electrons. That's the thing that's losing electrons. So we look at this and we're like, it doesn't look like much of anything's happening. This is an ionic compound. Let's write those ions. This is K plus and Cl minus. This is an element. This is an element. Their charges are 0. So when potassium goes from 0 to a +1 charge, is it gaining a negative electron or is it losing a negative electron? Losing. So it's losing. Which one is losing? Oxidation is loss. So the potassium is being oxidized. We can look at the other one, but we could also just say, well, if this is the thing that's being oxidized, then there's only one other thing. That's the thing that's being reduced. But let's look at it. It goes from 0 charge to -1 charge. That happens by gaining a negative electron. So this one's gaining electrons. That's the thing that's being reduced. That make any sense? This one is a little bit easier. So what's happening to aluminum? Is it gaining or losing electrons to become Al3+? It's losing electrons. Losing electrons, so that one's being oxidized. And the tin going from +2 to 0, gaining or losing? Gaining or losing? Gaining. If this one's losing, the other one has to be gaining. So it's gaining electrons. I know it's confusing with electrons being negative. When you gain negatives, you have to figure out how to make sense of that in your head, because if I try, I'm just going to make it worse. Gaining electrons, so that's being reduced. This one. We don't have an ionic compound here. We don't have any ions, so what do? Well, here we've got oxygen. Oxygen can't gain oxygen. Carbon. Is carbon gaining oxygen or losing oxygen? Here carbon is not connected to the oxygen, and now it's connected to oxygen. It's gaining. So this is gaining oxygen. That means it's being oxidized. Well, if the carbon is being oxidized, something has to be reduced. It's just the other thing. So this is being reduced. Questions? Yeah. Reduction is gain of electrons. If you're gaining oxygen, it's oxidation. So when iron rusts, it's oxidized. It becomes oxidized. It gets oxygen with it. It rusts. I know it's confusing. Any other questions? Yes, we can do one of these again. Let's see if there's more examples. Well, this is doing this again, but kind of with the agents. So now we're asked to identify the oxidizing agent and the reducing agent. So the oxidizing agent causes the other thing to be oxidized. I think the best way to approach this is to do what we just did, identify what's being oxidized, what's being reduced. And these are the same problems, so we're kind of just going over the same thing again. Here we've got an ionic compound, and we look at what's happening to potassium. Is it gaining electrons or losing electrons? It's losing electrons. Oxidation is loss of electrons. So potassium is being oxidized. So this is being oxidized. Chlorine is going from no charge to a -1 charge. That happens by gaining an electron, right? We add a negative charge to it, now it has a negative charge. So the chlorine is being reduced. So we need to identify the oxidizing agent and the reducing agent. The oxidizing agent causes the other thing to be oxidized. This is being oxidized. The chlorine is what's arranging for it to happen. So chlorine is the oxidizing agent. The reducing agent causes the other thing to be reduced. Chlorine is being reduced. Potassium is the one doing it. So potassium is the agent. I know, some of this stuff I'm like, oh man, I wish I didn't have to tell them this. They're not going to like this. This is going to be so confusing. I'm sorry, you know, some class that you take in the future is going to assume that you learned how to do this. Any questions about A?
So the majority of the time, would it just be opposite? Like whatever's being reduced is going to be the...
Exactly. They are going to be exactly opposite. The thing that is oxidized is the reducing agent. The thing that is reduced is the oxidizing agent. I was just thinking to myself, I'm doing so well with this, and then I just screwed it up. Yes, they are opposite of each other. Let's look at B again. So aluminum going from 0 to +3, does that happen by gaining electrons or losing electrons? Losing electrons. Oxidation is loss of electrons. So aluminum is being oxidized because it's losing electrons. So if aluminum is being oxidized, which agent is it? The reducing agent. Tin is going from +2 to 0. That happens by gaining electrons. tin 2 plus is being reduced. So tin 2 plus is the oxidizing agent. Somebody's getting it. It's confusing, but it's not like calculus or something. It's just too many little steps. And really the best way to be able to do this is just talk it out in your mind like I'm talking it out. You look at what's happening to that. How is that? Is that losing electrons? Is it gaining electrons? What does that make it? And then the agent is the opposite. This one's a little trickier because there's no electrons that we can tell. The electrons are moving, but it's not obvious. So here we have to employ the other definition that oxidation is gaining oxygen. That makes sense to me. I don't know if it makes sense to you, but oxidation is gaining oxygen. You can't use it in these because there's no oxygen there. But which of these is gaining oxygen? It's just the carbon. Oxygen can't gain itself. Oxygen is never oxidized. So this is being oxidized. The oxygen is being reduced. So who's the oxidizing agent? The one that's being reduced, the O2. And the reducing agent is the one that's being oxidized, the carbon. When you have a reaction like this where you have oxygen being involved, oxygen is always the oxidizing agent. Any questions? Sorry I had to lay that on you.